Hi, this is Jose Luis, and in my previous video on this series called Introduction to Parametric Modeling, I explained conceptually why NURBS geometry is so interesting and what are the main properties that drive it. So in this video, I just wanted to do a few quick examples of how can we actually model in a 3D modeling environment with non-NURBS geometry and with NURBS geometry. So here I have my Rhino viewport. The Rhino is a 3D modeling environment that is very popular among product designers, sometimes in architecture, but as well, it is very well known for having a NURBS kernel that allows for freeform modeling, which is super interesting. So if I have my UI here, and I'm just going to go directly to full perspective mode by double clicking on the perspective tab here. I can pan by doing shift and right click, and I can zoom in with the right mouse button, and I can also rotate with the right mouse button. So what I'm going to do is for example, here on my tab, I can create points, all right? And then, for example, I can create 1 point. I can right click and to repeat the action and create another point, another point, another point, all right? And then what I can do is I can, for example, now take these points, and if you have the gumball option turned on, you will see this kind of like small local coordinate system that allows you to move the point in three-dimensional space. So whatever it was, I'm just going to nudge it up a little bit, something like that, you know, and now I have these 3 points in three-dimensional space. I can also create simple lines. So for example, if I long click here, you can see that I can create single lines. So that's going to be a line between 2 points. I'm going to repeat another line between 2 points. And then if I click on the line, I can move the whole thing. Oops, I can actually extrude it. But I can move it if you just click on the arrow. I can move the line in three-dimensional space. And also, if I select the line and I press F10, what I will do is I will turn on the control points for a line, and therefore I will be able to modify just individually each one of the points. And now I have a line that is curved in 3 dimensions, that is inclined in three-dimensional space. I can also, if I long click, I can select polylines. So I can just click on a bunch of points and have this complex polyline show up. If I click on it, again, I can move it in three-dimensional space, etc., etc. But if I click on the line and I press F10, then I turn on the control points, and then I can start manipulating each one of them individually, which means that now I have given volume to what it was a planar polyline before. I'm going to delete all of this stuff, and now let's get to the good stuff. So I'm going to delete all of this, and I'm going to go to here to splines, all right, and to curves. And then you can see that if I long click, I have a bunch of options to create curves, but the first one is going to be a curve through their control points. What that means is that I can create a curve very similar to the one that I drew. And you can see that what I'm doing here now is I'm clicking the control polygon, and I'm creating the control points of the curve. Right now, this curve is infinitely smooth, and if I zoom in, no matter how much I zoom in, I'm never going to see any kind of discretization, because in theory, this curve is infinitely smooth. Again, it's defined by a mathematical polynomial, so I can find any smooth point on it. If I click on it, you can see that the control polygon shows up, and the control points that define it also show up, which means that I can take this point, for example, and I can move it like this, and you can see how the curvature just adjusted between that and that, you see? Or I can, for example, just move this one here, I can move this one here, or I can even move them in three-dimensional space so that the curve is not planar, but has some volume, you see? And then you can see how the curve is now a very smooth three-dimensional curve defined by the control points, right? Now, for example, what if I wanted to change the degree of the curve? Well, when you create the curve, when you click on creating the curve, you can see that before you start, it gives you the option to choose in the degree here. And by default, it's degree 3. So let me see if I can create two curves that have the same let me see if I can create two curves. So that's going to be, I'm going to create 6 points here. And then I'm going to create a curve through control points of degree 3. And I'm going to snap to these points. So I'm going to make sure that I have object snap turn on here on the options. Oops, sorry, let me escape here. I'm going to turn object snap, and I'm going to click on point. And I'm going to make sure that object snap is on, so that when I click here, degree 3, I snap to this point. 1, 2, 3, 4. All right, so that was the curve of degree 3. If I now click here and I say, no, I want a curve of degree 5 now, and I use the exact same points, you can see that the curve that I generated is much smoother. Well, let's do a degree 4. Well, this one, if I use the same point, is going to be somewhere in between both of them. So you see? So this is degree 3, this one is degree 4, and this one is degree 5. And you can see how all of them have the exact same curvature. What about degree 2? Let's do degree 2. And so this one, you're going to see how the curve is actually tangent to the control polygon at the center of each segment. So this one is control 2 and it's actually touching the curve at the center. And if I were to do degree 1, you will see how this will be simply just the control polygon, because it will be an actual polyline. All right, can you see that? Awesome. And now on top of this, there's actually other ways you can create curves. So for example, there is a very popular way of creating curves, NURBS geometry in Rhino, which is through interpolated points. What does that mean? Well, if you remember, for degree 3, 4, and 5, none of these curves is actually touching the original control points. And sometimes, for whatever reason, I may have a situation where I have points that I know that I want to go through. And therefore, creating a control polygon that is guaranteed to go through those points can be tricky. So that's why creating curves using interpolated points is a really good way, because if I click on the points, with this method, I know that the curve will exactly touch each one of those points. However, if I touch, you can see that what Rhino has done is that it has created control points automatically at the places where it knows that if those points are the control polygon of this curve, then that curve will pass exactly through the points that I had specified. So in a way, it's like creating the point is creating the curve the other way around. So instead of giving it the control points, I give it the points that I want to pass through, and then Rhino will figure out what the actual control points of that curve are. And then the last thing that I would like to show is how to create surfaces. So for example, because surfaces are defined by a cloud of control points, very typically we don't create surfaces by defining the control points. It's just very tedious. There's a lot of them. So typically the way we do that is by using operations that, starting from curves or starting from other primitives, end up giving us surfaces that have some kind of logic. And therefore, we also end up finding what the control points for that surface are. Very similar to the way we have created the interpolated curve here. So for example, I'm going to delete everything here, and I'm going to say, for example, I'm going to go to this panel and long click it so that we extend all the options. And you can see that, for example, I can have here a surface from 4 corner points. So I'm just going to create 4 corner points, all right? And if I right click here and I say ghosted, I can see a gradient, like a shaded representation of this surface. If I click on the surface and I press F10, you can see that the 4 control points show up. This is a very simple surface. It only has 4 control points. But you can see that I can start dragging it. And now that this surface has volume in three-dimensional space and looks like a parabolic hyperboloid kind of situation, right? So this could be a way of creating a surface. Now, another way can be, for example, a very common way is by lofting a surface. So for example, I'm going to go to the right viewport and I'm going to create I'm still using polynomial degree 1. I'm going to create three curves. Another one like this, and another one like this, for example. I'm going to right click. You can see that they're all in the same plane. So I'm just going to move one of them here and another one farther down. So you can see that now they look something like that. And now what I can do is I can click here and I can click on loft, and I'm going to select the three curves, the first one, the second one, and the third one. And as I right click, you can see that I'm given some options, normal, loose, tight, whatever, but I can press OK. And by pressing OK, you can see that I have created a smooth surface that passes exactly through the three curves that I had defined. And if I click here and I press F10, you can see that now I have this cloud of control points that define that surface. So in a way, it was a very similar process to the interpolation. I tell Rhino, where do I want the surface to pass through? And then Rhino calculates what are the necessary control points to generate that surface. And after that, I can mess with those points. So I can drag this point up, and you can see that the surface smoothly bumps up. And this one I can also bump the surface all the way up here, and then the surface has now this bump here. And the idea that by dragging in and modifying the control points, I can create smooth variations on the surface of the object, is one of the powers of NURBS modeling. And it's one of the powers that make it so attractive for free-form modeling. Okay? So there are many, many ways of generating surfaces. So if you long click here, you can see that you can do it by doing spliner surfaces from a network, loft, from degree, from edge curves, from patches, but with extrusions, point extrusions, you can do sweeping, you can do revolving, you can do a lot of things. But we will explain more of those in further videos down in this series. Okay? So now, and of course, sorry, I forgot. We have surfaces, and in Rhino in particular, we have this thing called B-reps. B-reps means boundary representation. And what that basically means is just that by stitching a lot of surfaces together, you can create something that feels like a solid object. So for example, I can create a cylinder here, all right? And you can see that this cylinder is basically three surfaces. If I click here, you can see, and if I explode it, you can see that it's one surface here, then it's the cylinder surface, and it's the other one here, right? So this is the concept of B-rep. B-rep is just a collection of surfaces, typically that enclosed a watertight space, a space that has no gaps inside of it. And for us, it gives us the impression of a solid object, but it's not really solid. It's just a bunch of surfaces together. Same goes here, so you can do a bit more complex stuff, like for example, you can do a torus, right? And this is also, in the case of the torus, this is actually one surface, which is bent on top of itself. Or for example, you can do like a truncated cone, for example, or something like that, right? Where you can see clearly that is also, again, three surfaces stitched together. All right, I think, and this idea, let me do a sphere, for example. If I have a sphere, I can generate a sphere, and the sphere will be this continuous surface that is wrapped around itself. This, as you can see, is infinitely smooth because it's a mathematical sphere surface. If, for instance, I were to create a mesh, for example, let's create a sphere that is a primitive, and I'm going to create it here, right? And I'm going to do the same thing. You can see that if instead of using a brep object, what I create is a mesh, then it turns out that the quality and the nature of the two geometries is very different. This sphere is made up of a series of discretized faces, each one of them being a quad. So each one of them having each one of them being a planar quad made out of 4 edges, right? And then these triangles here on the top. And this is just basically a collection of points and a collection of edges that join them together. It doesn't have any mathematical entity inside of it. It's just vertices and faces joining each other. I will explain a little bit more of this farther down in this tutorial series. Okay? Now, I think this was enough for a modeling introduction to NURBS geometry. Let's take a look now at how do we handle NURBS geometry inside of Rhino. How can we inside of Grasshopper, how can we generate, create, and modify NURBS objects inside of Grasshopper, which is one of the most powerful features that the software has. So let's take a look at that and how it relates to parametric modeling in general. And of course, if you like these videos, consider subscribing, liking the video. Thanks a lot. See you on the next one.